Come back to this one later. I really want to take care of that primitive obsession. So let's see if we can make some progress on that. And what I was thinking there is that we've got this capital gains tax rate. It would be nice to pull out the concept of a tax rate because we see that dealing with integers that are 100 times bigger than they're supposed to be instead of dealing with floats is getting a little messy. And I think that's actually going to clean up a lot of this code. It's going to make it read really cleanly. So I'm going to start putting in a tax rate object. We'll see if we can get through it in this video. Probably not, but I really want to start getting that in. So let's go ahead and make a new tax rate. I could try to factor it out of what I've got here, but what we've got here doesn't really talk about tax rate so directly. So what I'm going to do is make a brand new class, write some tests around it, code it up, and then integrate it with the rest of the code. Just make sure everything is out there. So now that we've got our tests running, let's go ahead and do something here. I think what we want to do is we want to say, well, let's just make a new tax rate and pass in 0. So, and assert that our tax rate dot tax for $1,000, the tax rate of 0 should be 0. Let's start. Now I'm passing in an integer here. I think I'm probably going to want to do a float at some point, probably fairly soon. In fact, let's do that now. We're going to pass in a float. And I could actually do a percentage object, but I think that would be going too far. So I might want to do that in the future, but not now. This, however, is probably going to turn into a dollars object. That seems to be a pretty fundamental domain concept, so I'm going to want to do that. Okay, there's our 0 was 5. I can just hard code the answer to that for now. Let's get another test in here. So I think our simple tax is just going to be, 25% of 1,000 is 250. Still really not sure about using floats, or let's make it a double. I don't know if it really matters, but I've always felt that when you're dealing with finances or anything where precision is generally important, you shouldn't use IEEE floating point math because it's not precise. So I tend to use integer math or big decimal type of stuff. Actually though, for this particular application where it is long-term projections, precision isn't that important, but it could lead to obscure little failures in the test where I'm expecting 266 and it comes back as 267. So I think I'm probably going to use a big decimal here or something, whatever the Java equivalent is, if that's not the right thing. So, but I'm going to come back to that. Again, this amount and this result, these are really dollars, and we will make that class fairly soon. Okay, we've got this working. Let's go ahead and make it a big decimal. I'm not sure if that's the right thing in Java, so let's see what happens. Well, it looks like it is. Let's just take a look at this. Yeah, arbitrary precision signed decimal numbers. I'm going to apply that division after I have the big decimal, and the reason is that it will be more precise. Okay, so let's get this working. Java does not have great support for building your own types. It doesn't allow you to do operator overloading, so this is a bit clunky, but I think we can make it work just by doing that. I've not actually ever used big decimal before, so I should probably slow down a bit and just look at these and make sure they work the way that I think they do. Wow, okay, so not being a math guy, that description doesn't make any sense to me. Oh man, let's look at that again. Okay, so there's some scale built into big decimal. I don't know what that means. But you know what, if this works, I think I'm okay with it. That's so cheesy of me. All right, we are losing information when we do that. That's interesting. I'm going to just go ahead and take that risk because what that would mean is that the amount would have to be more than $2 billion. And if I have that much money, I'm not going to be using this program to manage it. So It's one of those assumptions you get. I mean, I was making that assumption all along, but now it's explicit. It bothers me a little bit that I'm not documenting it or anywhere. But at the same time, I don't really feel like spending time on the video to deal with it. It doesn't seem important. So I'm going to leave that defect in here, intentionally so, and I'm not going to document it. If anybody ever comes along and puts in more than $2 billion, it will fail. So that may come back and bite me in the future, but I would be surprised if it does. Okay, so now we've got our simple tax working. I'm going to make this a little more clear. Let's call this simple tax. And we're going to say simple tax applies tax rate to amount. Just applies tax rate to amount. But the compound tax, which is what's happening when we're in our actual stock market year, compound tax, for lack of a better name, there's probably a domain term for this that would be better than compound tax, maybe. But compound tax figures out is the amount of tax that is incurred if you also pay tax on the tax. And that, I believe, we've established already in previous attempts that that's 333, but let's calculate that one more time. Yeah, it's 333. Okay, so that is going to be, this big decimal stuff is so unreadable. Okay, the formula is amount divided by 1 minus rate minus amount. So we're going to want to return I mentioned that this stuff is unreadable. Blah. Oh, disgusting. That's just terrible. Okay, forget it. This is terrible. This is oh, this is so bad. I don't think I care as much about having exact results as I care about readable code, and this is just so very nasty. So yeah, wow. It's oh my god. So yes, I'm refactoring with everything broken. That's terrible too. But this is actually pretty simple if I don't deal with big decimal. Maybe some of you out there know more about Java than I do and will chime in the comments about how there's a much easier way, but oh my god. Okay. Sorry. I'm just astounded. Sometimes the Java folks, I really think that, you know, they create these elaborate architectures that allow you to do some great things, but sometimes I think that they get lost, completely lost in making everything possible and nothing easy, and certainly not simple. Okay, so I'm not going to spend this video ranting. I apologize, but oh man, just comparing those formulas. Oh boy. Okay, so now we've got our simple tax rate, our compound tax rate. Let's go ahead. Now what we haven't done is we need to do some assert on tax rate. Need to enforce legal values. I don't want to do that right. Normally I would do that right now, but I don't have my fail fast code set up properly yet, so I'll come back to that later. I don't really want to spend time in this video on it. I might actually do that off camera. So there we go. There's our tax rate. So now I think we can get this in. Am I forgetting anything? I don't think so. Let's get this puppy in there. As a temporary thing, as a purely temporary thing, to get this into the code, I'm going to add a rate method, and I'm not putting test around this because I actually intend to delete it. Yeah, of course that passes. I didn't write test around it. The reason I want to do that is because I'm going to change this into a tax rate. But I'm going to do this pretty slowly. Oh, you know what we forgot? This is important. We forgot to make this a value object. So I'm going to fix this now. Value object, of course, is an object that is going to pass the equals test, even if we've got different instances of the object, as long as the values inside are the same. So given tax rate, I've done this particular batch of code so many times. I could do it in my sleep. Okay, I just put all that in because I've done this test so many times. You kind of need it in there, but yeah. And I'm cheating badly here. But again, this is really straightforward stuff. I don't expect it to go wrong. So you know what, let's just go ahead and toss the toString thing in here too. Okay, so we expected 33%, but we didn't get it. I don't really care about the value of this right now. Okay, we are just about out of time. Let's see if I can get this in real quick. There we go. All right, we just finished getting tax rate to be a value object. Let's go ahead and finish up incorporating the tax rate into stock market year. So I'm sneaking up on this pretty slowly because doing this sort of extraction of a primitive can be challenging. So right now I'm just pulling the primitive out. I have a note to take that code out, but as I said, I'm going to do this pretty slowly. So let's turn this into a tax rate, which means that this down here be like that, and this to be like that. Okay, now we will make that a real object. Failed. It probably failed because we're now comparing an integer to an object. There we go. Is that it? Do we really have it everywhere in here? No, we don't quite have it everywhere in here. So this is neat. This is where the pulling that code out really pays off. We should now be able to just say capital gains tax rate dot compound tax for capital gains withdrawn. And that is fantastic. I hope it works. Perfect. Awesome. So that is exactly what we wanted. Now that was a messy piece of code that had to do the doubles and everything. Now that's all just hidden away. In the future, if we decide to bring back that god-awful big decimal thing or change the underlying data type or whatever, it's completely hidden from us. It should just work. So perfect. I mean, that's what's happened when you kill off those primitive obsessions. So I think that's it for capital gains tax rate. Let's go ahead and take this back out, and if we have truly eliminated it, yeah, then all the tests pass. Okay, so the next primitive obsession we have in here is the interest rate. So that's going to be pretty much the same thing. I might actually fast forward through this part of the video because it's going to be really similar to what we just did. Okay, that's done. Now you may be wondering, this code is very similar. The interest rate code and the tax rate code is extremely similar. And you may be wondering, why didn't I just have them inherit from a common base class, or even just make them both a rate? And the reason is that I think they represent fundamentally different domain concepts. I could have created a percent class and delegated some of the work to that, but it really wouldn't have saved me much because most of the work is in boilerplate. So I think these are fundamentally different concepts. I think they're going to diverge over time. We can already see that interest rate, we just get a simple interest rate, and the tax we have the cover the tax rate. And I don't think there's going to be a similar concept for the interest rate. So even though the code right now is similar, they represent fundamentally different concepts. So I think they should be represented through completely different classes. And I don't think you can say that they are both examples of the same kind of thing from a domain perspective. Or at least I don't think what you gain from doing that outweighs what you lose in terms of tying these things together prematurely. Now, if I'm wrong and more duplication shows up, then I might change my mind on that, but for right now, that's how I feel about it. So let's go ahead and get this interest rate in here. It's going to be very similar to the last way we did this last time, in that I'm going to go ahead and toss in a method that we can delete. And again, I take these very slowly because I know from hard-won experience that it's easy to get this wrong. Okay, I think I've got everything in here. Now I just need to fix this. And so that should be yeah, great. Okay, can get rid of this now. And let's see how this reads. So capital gains withdrawn. Yeah, I'm liking this. Great. Great. Okay, so I think what we have to do next is the dollars. And the dollars, of course, will be the end of the primitive obsession. We'll turn these into dollars, and then we won't have any more problems.
Last time, just starting to look at the concept of dollars. And I stopped because I'm not sure how I want that to work out. I don't want to end up with the same sort of debacle that we had with big decimal, where we have something that's fairly easy to read here, where we can say, for example, starting balance minus total withdrawn, or starting balance minus total withdrawn plus interest earned, and replace that with starting balance dot subtract total withdrawn dot add interest earned. But at the same time, I do think that dollars are a fundamental concept, and that if we replace our int with dollars, that will be a good thing. And it is very difficult to replace a primitive with a class if you wait too long. So, and it should be pretty easy to replace a class with a primitive, although I've actually never wanted to do that. But using the inline refactoring should allow me to go back if this turns out to be a mistake. So that's what I'm going to do. I'm going to go ahead and write the dollars class, and if it turns out to be a mistake, then I can fix it. I'm pretty uncertain about whether or not it's the right thing, but let's go ahead and give it a try. I think I will start by just making this a value object. Okay, let's stop here and just get this to compile. Okay, I'm going to try to run the test on that. Passes, of course, because I'm not asserting anything. And oh yeah, let's do the string. Okay, so there's our boilerplate value object stuff. That should fail. Yeah. Yep, okay. Alright, same old, same old. Okay, let's do something interesting. So let's look at stock market year and decide what we want. What are we doing with dollars? We are adding and subtracting them, and that seems like something that's really central to what a dollar concept should do. We also have this -1 times, and multiplication doesn't feel to me like something you should do with dollars. So we're going to come back to that one. I have an idea about how to deal with it, which involves looking at this whole thing here and saying that's really what we want to abstract out. I would love to get rid of this math.max thing anyway. So let's get addition and subtraction in there first, though. Okay, so again, we're seeing the same problem we had with big decimal, which is that this is just not reading clearly. And that's kind of just Java's problem. Java doesn't have operator overloading, and I can see why operator overloading can be abused pretty badly, and I'm pretty sure that's why they didn't put it in. But when you're creating a new value object, something that actually, as a basic type, can do addition and subtraction and so forth, not having operator overloading really makes the code harder to read. I don't know, I don't follow the latest Java news, so I'm pretty sure they don't have that yet, but it may be on their radar. Let's see, add dollars. Well, I think that reads clearly enough. We could call it a addend and subtrahend like Big Decimal did, but I think this is just fine. Okay, so there's our addition. For subtraction, we have to ask about positive and negative results. Does it make sense for a dollar to have -$30? And I think in this context it does, at least for now. So let's do that. So we're going to expect 20 and let's subtract 30 from 50. Oh, that's going to fail, of course. Expected 20 was 0. What did I do wrong? Oh, yeah. All right, and let's look at the negative result. I don't expect this to fail. The code we've just written should be just fine. But I want to put this in here for the sake of documentation. So if somebody in the future comes along and says, how does this work when I subtract a larger number from a smaller number, they can see that it works just fine. Okay, there we go. Now, I could integrate this, but it's not quite ready. I want to take care of this. And what I was thinking about, it'd be interesting to have a method called subtract to 0, which basically says that we either give you a positive result or we give you 0. Okay, there's our failure. So I think, there we go. Great. Okay, now let's go ahead and integrate this. And again, I think to integrate it, we're going to need to go ahead and put in that temporary amount. And then we can start getting it in. And again, I go very slowly on this stuff. My use of methods instead of instance variables just paid off. I was able to do that rather than have to make a big change. Okay, where did that fail? Okay. Let me see if I can just quickly get in this piece right here. So I should be able to say return starting principal subtract to 0 total withdrawals dot amount. Not very clean. Hopefully that will work. Yes. As I was afraid of, this isn't really that much more clear. I think it will get better because we can start converting some of these things into dollars and have ending principal return a dollars rather than an amount. But it's, it's pretty iffy. But hopefully it'll get better. I'm going to do the same thing here. I think I can just flip this equation around so I can say total withdrawals, new dollars, total withdrawals, subtract to 0, starting principal, and then the amount of that. Does that give us the correct answer? Yes, it does. All right. Let's go ahead and get starting balance in as dollars, and then we'll convert everything else over as well. Again, take this really slowly. I could just sort of hack it in, but my experience, I actually, in public, doing a training course, tried to fix a primitive obsession by taking big steps, and I screwed it up so badly that half an hour later, in front of an audience, after flailing for half an hour, I decided to revert to what was in version control, and then discovered that the network wasn't working and version control wasn't working. It was a complete disaster. And from that experience, I have learned the very, very hard way that if you're going to deal with primitive obsession, take it in small steps, because it's really easy. It looks simple, but it's really easy to get to a point where you can't solve the problem. So let's see. And I haven't done it yet, but I do plan to put all this up on GitHub or somewhere like that. I don't know, it always bites me. And that one always bites me too. That's why I take it slow. I always forget about these little things. Despite, having done it 4 times now in this video and countless times in other projects. Okay, so let's see, I think we can have this be $1 now. Let's make a note that we want to take dot value out of next year test. Because eventually we won't need it, but the test won't fail. So I just want to make a note that we need to do that. Okay, so I think I can now start pulling out the dot amounts. Let's see. How do I want to deal with that? Let's convert, everything's working, right? Yeah, let's convert total withdrawals to dollars. Just gonna keep sneaking up on this. Okay, so that's going to be convert, we're going to want amount to dollars. So you can see why eliminating primitive obsession can be a real challenge if you wait too long. It's already kind of a pain in the butt, and I haven't actually waited that long. Okay, and that is now dollars. Okay, so total withdrawals are now in dollars. Let's go ahead and do this one. Oh, yes. I knew this would happen eventually. And this is, I don't know, this is ugly, I feel like, having to just do this new dollars everywhere. But I don't want to create constants called $1,500, etc. So, I don't know. I think this is a case where the tests are ugly, but the actual interface is pretty clean, because when we use it for real, we're not going to be doing this manual typing in of dollars. We're going to be taking a value from the UI, converting it to dollars, probably in just one line of code for each UI field. So, and possibly abstract even that. Okay, well, everything's working there. Now, let's start having each of these return dollars. So capital gain withdrawn, dollars. That's, of course, going to fail. Actually, that didn't fail. I guess we are not directly testing. Oh, that was a private method. Haha. Let's have this return dollars. Well, that's interesting. Let's skip that one for now. Okay, I am expecting that to fail because now I'm returning a dollars instead of a integer. Now I could say year.total withdrawn dot amount, but I actually want to get rid of the dot amount method. And the reason for that is that if you've got a value object, you should be able to operate on that object as the object. If you have a method to expose the internals, which sometimes you're going to want, but if you have that method, you're going to be really tempted to just pull out the internals all the time and operate on that. And then you're starting to violate the law of Demeter, or the pleasant guideline of Demeter is really what it should be called. And that can be bad in some circumstances. The law of Demeter was the law for a project called Demeter. It was one team's law. I don't think it's a general design law, so the name's a little unfortunate. But it is still good advice. Anyway, let's move on. What else is failing? Capital gains tax, right. So here. And what I've been thinking about, I knew this would come up, so during the break I was thinking about this problem of having to say new dollars everywhere to do the equals. And I thought maybe I'd want to factor out my own assert equals that allowed you to compare an integer to a dollars. But let's see how it works out. It may actually not be that bad. So is everything working? Well, in that test it is. Everything is working. Great. So now I think we should be able to say dot subtract and dot add dot amount. There we go. All right. Now let's just continue on. We can have this return. Well, that's an interest rate, so let's not do that. Let's have this return of dollars. So the interest rate and the tax rate need to deal with dollars instead of integers as well, and we'll get into that. Definitely not as clear. That bugs me, but I don't think I have another option in Java. Suppose I could write a method called total, which would take a variable number of parameters. If this continues to be a problem, that's something for me to consider. Looks like I was wrong about the test not failing. So there we go. I was just about to have ending principal return dollars. So let's go ahead and do that. It's going to fail because all of our tests are operating on integers. Still wonder if maybe I should have my own assert equals method that takes dollars, or an integer and then dollars. That might be nice. Well, let's see how cleanly it reads. I don't know if I want to do that. I kind of like, the reason I'm not sure if I want to do it is this is really nice and explicit, and I like that. Okay, so right here we've got interest earned. That needs to be operating on dollars. So let's take what we've got, which is working just fine, and pull up tax rate and interest rate. And we're going to feel a little bit of the pain of the duplication between these two classes because we're going to have to do the same work twice. But again, I do think these are different concepts. I'm expecting that much in the long term, or actually past now, we're not going to have a lot of duplicated work. And if we do, then that's a clear signal that I need to do something else. Okay, so that doesn't compile. Okay, so that passes. Now, oh no, it doesn't. What am I doing wrong? Oh, right. Now all this is going to require dollars. Well, I'm not going to just tack that in. I'm actually going to, well, this passes, right? Yeah. I think I am going to just have to sort of hack that in. This is going to be a bit weird. I don't want to use the new subtract method because I am trying to take very small steps. So, okay, now I'll use the new subtract method. Great. Okay, so back here, I said that I didn't want to keep amount public, but I'm not sure how to do this cleanly in any other way. I mean, I could say apply interest to dollars, but that's just moving the work out of interest rate into dollars, and I don't see that being a great thing because in tax rate, we've got this equation, which is very domain specific, compound tax 4. I don't know, I wouldn't want to put that into dollars, I don't think. So I think this is a case where I'm going to want to leave the amount as a public method. Because, or I could introduce a multiply parameter, but, well, let me just stop and think about this. I'm going to pause the video and sort of cogitate on this and get back to you. Okay, I'm back. I was looking at this tax rate class, and this piece right here, if I were to try to have divide and multiply inside of the dollars class, this would be ugly. I mean, it'd just be ugly. So I think what I want to do is actually introduce or keep this as a public method, which means that I need to write some proper tests around it. So let's go do that real quick. I'm going to call that toInt instead of amount to really emphasize that it's a data conversion. And of course that is amount. Now I expect that to pass. Yeah. Now we'll rename that and copy it. Okay. So what that means is, yeah, amount.toInt times rate, and then good. And inside of tax rate, oh, I'm taking two big steps, aren't I? Let's back that up. Okay, and let's go ahead and factor this out. Okay, go something here. Well, that was nice. Okay, yeah, so now that's reading nice and clean again. Now what we need to do is have these guys return dollars, which is going to break all kinds of stuff. Now I could have a constructor on dollars that took a double, but I don't want to do that just yet. That's passing, but something else should fail. No, I guess not. Why did simple... Oh, we're not using simple tax for it anywhere. That's why it didn't fail. Why did I write a method that we're not using anywhere? Maybe I shouldn't have, but it did just seem like part of the domain here. You're really not supposed to write methods you don't need, but I thought it helped communicate a little bit the distinction between simple tax and compound tax. I don't know if that method will ever be used, so writing it was perhaps not a great idea, but it's only one line of code, so I'm not going to stress about it too much. Yeah, so there we got that test passing. If I were just looking at the green bar, I'd be like, yay, great, everything's good, except that our code doesn't even compile. But, oh man. I don't really want these videos to turn into Jim's daily rant, but it really bugs me that Eclipse doesn't run all the tests by default. It is useful to just run one test or a set of tests occasionally, but by default, when I press that button, I want to see all the tests run. So tax rate, I believe, is now completely deprimitived, obsessive. Yeah. So I can get rid of that. Now let's move on to interest rate. Okay. Go over here and great, everything's working. So I believe interest rate is now deprimitive obsessed, and that's done. So now we just have stock market year left and 2 minutes left in the video. Can I make it? Maybe. Let's see what we can see. That's going to cause that to fail. Test should fail now. Yep. Okay. And interest earned is now going to be dollars. Failure. All right. Okay, so I think we have actually taken all the primitives out entirely. We've got some nice clean code here. Total withdrawals, subtract 0, starting principal. This could possibly be cleaned up a little bit, but wow, I mean, compare this to what we started with and how confusing it was. I'm really happy with this code. We'll see you next time with something completely new, UI perhaps.